So the MySQL provider, so it's the USDT provider. It was added to 608 and 5130 if you're using enable DTrace. And as I said earlier, these static providers and the probes have been designed for ease of use, and they've been designed to be a stable API. You can do some magic things with one-liners, and of course that's how it's been designed to work. For example, I can run dtrace -n. This probe is MySQL query start, and I can print out the query strings. I can count, I can frequency count the queries. I can do row event counts, lock event information. So you can come up with some neat one-liners. And when you write scripts, they don't get too long either. For example, this says, query start, record a timestamp in something called a thread local variable. I'll talk about the DTrace syntax a little bit, but just enough for us to get through, to have a basic understanding. We're recording it, this is a high resolution timestamp. We're recording it to a thread local variable, which associates it with that query. And when the query finishes, this is called a predicate. It checks that we saw the start of the query. When I say high resolution, it's actually recorded in nanoseconds. We can then do the delta of now minus start, and then use a DTrace aggregating function called quantize, which gives us the distribution. This is a power of 2 distribution. I just put the text string ns in. The at is actually a prefix for a variable. Then I'll reset the self-start thread local variable. That's the output for that kind of longer one-liner. It should be a little script, but it's able to trace the query latency from MySQL, and DTrace is summarizing it inside the kernel into this distribution. This one's a power of 2. It shows the time on the left, so this is actually nanoseconds. On the right, we've got the count of how many queries fell into that range. And in the middle, there's some ASCII art so that you can visualize the distribution quickly. So straight away, I can see most of the query time for while this script was running was between 131,000 nanoseconds, which is 131 microseconds, and 262 microseconds. Or in other terms, that's 0.1 and 0.2 milliseconds. So our queries are returning very, very fast indeed. We're not even getting anywhere remotely close to, say, slow query times of 1 second and longer. If there was any other interesting patterns that would spot out, you'd be able to spot them in the distribution. All I did here was I called it nanoseconds. You can record this distribution plot and break it down by the query string, username, database, all sorts of other information. They're available because the MySQL USDT provider has been designed to make them easily available. And you can include them in your scripts using actions like copy in string arg0 for the query string, arg2 for the database name, username, and the client host or IP. This term copy in string, if you're new to DTrace, that's necessary if you have a string or a char star in a userland application like MySQL, and you'd like DTrace to read it. Now, DTrace runs inside the kernel, which is a different address space, and so it has to copy in the string from userland into the kernel, and there's a convenience function called copy in string. So copy in string takes a null terminated string from userland and then makes it available so DTrace can use it. Just to show putting those together, this is a script from the DTrace book. It's also online. It's snooping the query time and providing other details. So we've got time in milliseconds. There's the database string, user at host, the actual query latency time, the return result, and then the query string. So that's the start times on the left. That does event-by-event tracing. Given all that information, so your query latency, query string, users and host database, you can present this other ways if you like. So I could present that into a summary, like one of those distributions. DTrace has lots of other actions for doing averages, min and max. Maybe instead of every event, you wanted a 1 second summary, like an IOStat type of tool. So all of those things can be fairly easily created, given that MySQL provider. That script, I don't have it in the slide deck, but it's on dtracebook.com. The DTrace book is 1,000 pages and contains over 200 scripts. I'm not going to make people type them out, so all the scripts are available online on dtracebook.com. And so that one was the MySQL DQ snoop. And this entire script that was doing that is it's only about 30 lines long. And it's instrumenting the start of a query so that it can record a timestamp and fetch information, and then the completion of a query so that it can do the deltas and print it out using a printf statement. You don't actually have to know much DTrace or C, which it's inspired by, to be able to follow this script, which is the intent of these statically defined providers. They make it easy for us to roll very powerful scripts fast and answer questions. That's just query start to end. Other probes exist for looking at connection events, command, query, query pass, query cache, query execution, row events, index reads, locks, file sort, statements, network, and the key cache. And I had the website up earlier that lists them all out. So you can write a number of powerful scripts that will you run the script when you need to, Control-C, and it stops, everything goes back to normal. You can fetch that information as required.